just minimize the radicand, because the smallest possible the square root of the smallest possible number will be the shortest distance. So we just have to worry about the part under the square root. So now when I plug in my x and y's, I've got x minus 4 squared plus y minus 0 squared. I simplify that. I use my secondary equation of root x to substitute into the primary so that I can get it all in one variable. Now I can do the derivative. I've got chain rule on the first term and power rule on the second. I set equal to 0 and solve. So that's the x-coordinate of the point on the curve that's closest to 4, 0. I plug that into my secondary to get the y value, and it becomes 7/2 root 7/2. Oh, I'm going to just, for the PDF, I'm going to because I just realized I went on to the next page. I'm going to say that x equals 7/2, and then I plug it in to get that. Okay, so now we're on 14. We want the point on the curve x plus 1 squared closest to 5, 3. So x plus 1 squared looks something like this. 5, 3. Just based on the picture, it looks like there's only going to be one point that's closest. I can't really pause this. What's up? All right, and we're good. You know everything you want to do. What do you want for tension? 55. 55? All right. And it's the ALU power spin? All right, man. Thanks. I'll have that done today. Are you getting out there today?
Yeah, probably.
What time? I'll have it done by then. All right, so I'll contact you. Yeah. Sorry about that. Okay, so we want to minimize that distance. Now, what I was saying was that based on the picture, there's going to only be one point that's closest to 5, 3 on the graph. That's important when we're trying to find our zeros later for this problem. So again, we're going to do the distance formula is the square root of x minus x squared plus y minus y squared. So we're just going to worry about the radicand, and we're going to plug in our x's and our y's. So I've got x minus 5 squared plus y minus 3 squared. I'll use my secondary equation to make my substitution in here for y so that I can get the primary, the thing that I'm minimizing, all in one variable. So now, oops, I am just I'm squaring the x plus 1. All right, so now I'm going to do the derivative. I've got two terms, chain rule on both of them. So that's the first one. Second term. So now I want to find the critical numbers for this. There isn't a common factor. So because these powers here are 1, I'm just going to multiply everything out. So in the first term, I distribute the 2. Whoops, distributing, like I just said. Then I'm going to multiply. I like to multiply the polynomials together first here and then distribute the 2. So I've got 2x to the third plus 2x squared plus 4x squared plus 4x then what was I? Minus 4x minus 4. Now I'm going to distribute the 2. So I got 4x cubed plus 4x squared plus 8x squared. These equal 0, so I'll skip those. Minus 8. So now if we collect like terms, I got 4x cubed. Now we'll do squares. I got 4 plus 8. Then we'll do the x's. It looks like I have plus 2x. Then the constants looks like negative 18. There's a common factor there of at least 2. And now I try to factor that further. I try grouping, it doesn't work. So what I need to do next is the rational roots test on this polynomial. So I take the factors of 9, which are 1, 3, and 9, divide by the factors of 2, which are 1 and 2, and I make my possible list. It's plus or minus. I'm going to go 1 over 1, 3 over 1, 9 over 1, 1 over 2, 3 over 2, 9 over 2. So I've got 12 possibilities. You have to test them all. You could use your calculator to graph this polynomial to kind of cheat a little bit and see which one works so you don't waste your time testing them. So I know that 1 works. So I'm going to divide 1 out and show that it works. So I've got 2, 6, 1, negative 9. Remainder of 0. So that means x minus 1 times, I have this 2 out here, so I'm going to carry the 2 over. X minus 1 times 2x squared plus 8x plus 9. So that's 2x squared plus 8x plus 9. Now for n equals 0. For a number of reasons, I know that 1 is the only 0. This will not produce any zeros. One reason is if I do the quadratic formula, I'm going to get a negative under the square root part, which means there's no real solutions. Another reason is the picture that we kept in mind. There's only going to be one point that's closest. There can't be more than one. I'm going to assume that because of that, there's only the 1 0. But again, you could do the quadratic on that. 2x squared plus 8x plus 9. And you would see that you get a negative under the square root. So once we have 1, I test in my derivative,
yes, you did.
and I get minus plus.
Continue.
I know I'm gonna do that for you like right away.
Talk instead, or do you wanna?
No, I'll do it for you.
Okay.
I have time this class.
Okay, cool.
Thanks. All right.
Mom's at like 8.
Okay.
Thanks.
Yep. So that's the minimum at 1. I plug 1 back into the original equation, which was x plus 1 squared. So I get 4. That's the point that's closest. Number 16. We're talking about the flow of traffic and the velocity of cars. The formula is given by this. I do not need a secondary equation because there's only the one variable of v. There's not much simplification to do here, so I just go for the derivative. It is going to be quotient rule. So f prime is 1 times g, which is 22 plus 0.02 v squared, minus f times g prime, which is 0.04 v, all over g squared. Up top, when I simplify, I've got 22 plus 0.02 v squared minus 0.04 v squared, all over 22 plus 0.02 v squared squared. Simplify further, and I get 22 minus 0.02 v squared up top. And on the bottom, I get 22 plus 0.02 v squared squared. I just combined the v squareds. So on the bottom, since I have v squared plus a number, I know that that's not going to produce any zeros because I'll end up trying to square root a negative. But the top will produce zeros. So I go 22 minus 0.02 v squared equals 0. I add the v squared part, so I get 0.02 v squared. I divide by 0.02, I get v squared equals 110, I believe, but give me a second. 22 divided by 0.02. Oh, 1100. So then I square root that. I get approximately 33.2 miles per hour for the velocity. I put that on my test interval. And I want to maximize the flow rate. So I plug the stuff in. It turns out plus minus. So I know it's a max when the velocity is 33 miles per hour.